Hi, everyone. So today we'll get started with reacting in real time, talking about guardrails and active monitoring for LLMs. We'll give just a couple of seconds for people to start trickling in and then go ahead and get started. And I'm sure more people will trickle in as we get through the introduction. If you're already here, though, would love to hear from folks in chat where you're located and if this is your first workshop of Y Labs. This is very much not my first workshop. I've done quite a few, but really excited to talk about guardrails and active monitoring today. I think this is the first of that topic that I've done in this format. Okay, let's go ahead and get started. So again, this is reacting in real time, guardrails and active monitoring for LLMs. I'm Bernice Herman, Senior Data Scientist at Y Labs. And, let's see here. Get my mouse, there we go. So just a little bit about me. So as I said, I'm a Senior Data Scientist at Y Labs. Do lots of different work on approximate statistics, machine learning, real-time monitoring, data-centric AI approaches. I also do research in another role at the University of Washington related to evaluation metrics and synthetic data generation. So very much a big fan of this sort of thinking about how well our LLMs or our machine learning models are working all the way around. One of my favorite topics to think about. And so at Y Labs, there are many, many activities going on, but my focus is particularly on the kind of metric selection, compression, monitoring, and anomaly detection algorithms in the company. And so you'll see evidence of those both on the two open source projects that we see here on the left, LangKit and YLogs, as well as the monitoring and anomaly detection algorithms in the observability platform itself. So we will touch all of those topics, and I'm really excited to talk about them. So I'm excited to see in the chat that we have some returning attendees to the workshops. I hope that Y Labs becomes easier for you. This is my goal in the workshops, to kind of give you a taste of some of the complicated things that we'll do, because inevitably when you're installing these things in production systems and wrapping your head around how to monitor production systems, there's lots of edge cases and difficult things. But at the same time, hopefully we can continue to make it easier and easier for folks. So if you have anything, if anyone watching has anything, any comments or any thoughts on things that could be explained better, or would be easier for them, or that they'd like to see more materials on, please do reach out. You can reach out to me directly. My contact info will be later, as well as different places. I'll share the contact info at the end. Okay, so this is our agenda for today. We're going to start with passive monitoring, and maybe I'll give some reasoning on why I think that phrasing maybe doesn't do it quite justice, but we'll start with that. Then we'll move on to developing actionable metrics for complex data. So this is, like I said, metric creation and selection. This is something that I spend a lot of time doing. And we'll talk about why that's so important, especially in the world of like text models and LLMs and image models, but really in general, and trying to find actionable insights into your data. Then we'll move on to using metrics for active monitoring using manual guardrail thresholds. So this is going to be the bulk of our coding is going to be in this third section here. And this is really about, well, once we learn about active monitoring a bit, how can we come up with manual guardrail thresholds? So decisions about when do we trigger different actions that we're going to do, and what does that work in finding those thresholds, or finding those metrics and coming up with thresholds. And then finally, I'll give a little bit of a preview of the automatic guardrails in our upcoming YLab Secure product. There's actually going to be a launch very soon for this, so I won't give too many spoilers, but it's really relevant to today's workshop, so I'm going to give a little slight preview. Okay, and that's the agenda. Kelsey from YLabs is dropping in some links to notebooks and the slides and repositories, so please do use those links, in particular the Colab notebook, if you want to follow along with me today. Okay, so let's get started with passive monitoring. And I don't think passive monitoring has to be the way that you phrase this, but we'll talk about maybe some other ways to interpret it in a second. When we think about passive monitoring, or when we think about monitoring in general, I should say, we're often thinking about taking some data that we have, whether it's from a long time ago, historical data, or recently, but from your application, and trying to understand what's going on, trying to compare it. And what leads us to use the word passive, or just not quite as active as what we're going to talk about later today, is the fact that we're waiting until the full transaction with the customer, or the database, or wherever you're doing, whatever the final result of your model is, we're letting all of that calculation happen. Maybe we're logging or storing some information in the meantime, but we're not actually changing the logic of what we're doing in real time as a result of that monitoring. We're waiting until, sometimes only seconds later, the interaction's done, so we can take that data, aggregate it, and kind of understand how our system's working. So even though it might be only a second or less than a second after the interaction has taken place, it's not during the interaction that we're actually being able to see and understand the monitoring results. And so we can't really use those monitoring results to affect things. So we're going to go, so I've been using the word monitoring, but I think relevant to this sort of passive, or sometimes I think of this as post hoc monitoring, is not just monitoring. There's kind of three categories that I like to split out. So this is evaluation, monitoring, and observability. So let's go ahead and talk about those first. Okay, evaluation. So evaluation in machine learning is something that most people have encountered and worked with. I think even if you're kind of new to data science or machine learning, or any roles relevant to this, engineering, so on and so forth, this idea of evaluating a model is something that you've probably run into. And so what is kind of happening here? I have a picture of many different ways you might think about evaluating a model. Those aren't as important as kind of understanding what is our goal and what do we use to do that. So evaluation is about understanding, are there differences between what your model has produced, what predictions you've made, and some labeled test data, so some ground truth data that you have that represents, the right answer. And this is, many, many techniques that you've heard of and different metrics that you've heard of and used fit under this, right? So things like accuracy calculations and F1 scores, precision recall, all of these sorts of things require some ground truth information to calculate, as well as things like interpretability and sensitivity analysis studies, and even to some extent, different types of A/B testing and things like this, although you don't necessarily have to have labeled data for this. This all fits in this understanding of, are there differences between this data on the left and this data on the right? And what does that say about the kind of performance or quality of the model itself? Okay. And so kind of keeping with, how we typically learn this in data science and machine learning, we often learn to do this on static experimental data. So we've collected some training data set. Maybe it's historical data that comes from the business itself. maybe it's some data that we've collected from research or online, that sort of thing. We'll take this data. We will often do whatever work it takes to capture ground truth labels. Maybe we're really lucky and the application naturally gives us ground truth labels. But often we're not so lucky, and we have to do something like use crowd workers to look at data and come up with a label. Or maybe we approximate those labels using some information from the business. So, for example, I may not have a perfect label about which customers like a certain page on my website, but I could use something like the amount of time that they've spent on each page to serve as a weak label or proxy label for us. But either way, our kind of pipeline here is collect some data. It's static, and we typically don't think too much about when that data was created. But then we go capture some labels using some process. And then we split that data into a train portion, a validation portion, and a test portion. And using static data is kind of anytime that you're thinking, oh, am I doing evaluation, monitoring, or observability? If you're using static data and you don't have a lot of emphasis on the time stamp of when this actually occurred, this is often almost certainly evaluation. Because when we move over to monitoring and observability, this is really intended for kind of dynamic production data that is associated with a time, right? So you see here in this graph, the source of data that we're working with for monitoring and observability might have daily buckets of data that goes on, as long as your system is in production and deployed. And this doesn't necessarily always have ground truth. Ground truth collection, as I just talked about, is sometimes a pretty arduous and expensive process, and not something that is done kind of consistently every day or at a high frequency. But you can do monitoring and observability with ground truth. And if you're able to capture even a small proportion of your data at regular intervals with ground truth, that would be even better. But so we're going to kind of move our mindset from this sort of static data set to the dynamic production data, which is kind of a different way of thinking. As someone who trained in statistics and the beginnings of data science when I was back in undergrad, this is something like we focus very much on the left side of things, and I think it's not until you get into real world problems that you start to think a lot about the right side of things. Okay, so then what's the question that we can answer with monitoring, and how does that differ from evaluation? So if evaluation is about, are there issues and comparing to some ground truth, monitoring is much more about when are there changes or issues occurring in production. Right. And so this emphasis on when in this first version of monitoring, while we're still thinking about passive monitoring, is often going to be about, which day did this happen? Or it certainly depends on the frequency of your monitoring. So it could be, which 5-minute period or something like this, which day, which week, which year did there seem to be a big change between my data, the data before and today's data, for example. And this is helpful in a lot of things related to production systems and debugging, right? So even without the ground truth labels, what we know is that if there's a very large change between certain, segments of our data or the whole data set from yesterday to today, there's a chance that there's an issue in the model itself or in our system that surrounds that model. There is a chance that this has happened just due to changes out in the real world, which is still important to know, right? This will still affect the performance of your model itself. If the real world changes underneath you, you probably need to retrain your model or something like this, capture new data before you do that. But we can really get a lot of the debugging functionality out of just when did this change happen and on what segments of the data or what particular features of your data did this change happen. And so here's a picture here, an example from the Y Labs observability platform for some different charts that you can see that really hone this idea of monitoring. So we see this over time. We see different percentages across a number of models that you may have. Okay, and then let's go to the third concept before we go further, and that is observability. So observability is not just the when, but it's also trying to answer questions like how and where are issues occurring in the production system. So it also includes the when. We're still likely capturing the data, like timestamp data itself. But now what we want to do is understand, well, can we take these changes and finding these changes and actually help us to pinpoint what may have caused the issue, not just when did that issue exist, but what may have caused that issue. And to do so, getting some sense of where in your system or your pipeline that this happened can give us a lot of hints on how exactly did this happen. So this is something that is an important, I think, step. Even when people get to the place of monitoring, they often think of their whole system as like kind of one atomic unit. And that is still very, very helpful. Understanding when issues happened, it can be very helpful. You can look and say, oh, well, we just released a new model yesterday. This is clearly part of the issue, right? Or something related to this. These are the code changes that we've made in this time span. But what can be more helpful is injecting this agent. So while logs is kind of an agent, we'll see a little bit later, to help capture some of this telemetry. This agent, if we inject this in many places across the entire pipeline, now we can start to locate where in our system, where in this pipeline are these issues happening. Because not only do we see on what day this change happened, but we see, oh, it was between the step where we brought in the data and we transformed the data, right? So now we know that this data transformation looks different than we expected, and so on and so forth. Okay, so those are the main concepts and main way of thinking about these three concepts in the sort of passive monitoring, wait until you've done the calculation for your data sort of scenario. But what if we want to capture issues before the kind of final result has been communicated to the customer? And this is where we get this term active monitoring. So we're kind of monitoring, although I would argue certainly that monitoring itself is very active. Even when in our kind of passive monitoring, we're still using that monitoring to do things like retrain our model and deeply understand what's happening in our system, deeply understanding our customers. This idea of active monitoring is about capturing issues before we even communicate results back to the customer, because maybe we can stop bad things from happening, or cache or do lots of different things. Okay, so looking back into the same picture from observability, this is where we're going to add our fourth into what is normally my trio of evaluation, monitoring, and observability. And this is going to be what I'll use is the word guardrails. So now we're thinking still kind of a when question, which is why we also consider it active monitoring. But when in a single interaction are issues occurring, right? Not over the aggregate data set for the day or the last 5 minutes or something like this. But I want to know for every interaction, when inside of that interaction are issues occurring, and can we redirect the workflow or the logic to give a different result? And so we'll talk a lot more about some examples in detail, but just to give some color to this, this would be, for example, retry logic. You may have some logic that monitors the results of each interaction, but for a particular interaction, we notice that this result isn't quite what we would consider a positive customer experience. We don't want to send the result that the LLM gave us in our application. We will monitor, we will look at this result, we will kind of do some analysis of it. That's the monitoring part. And then we will maybe send a default response to fall back, or maybe we'll call the LLM again with a different prompt, trying to get a better response. Or maybe we will call caching. Maybe we've monitored a customer input coming in, and we realize that this looks very similar to other questions that they've asked or that are in our database. So we don't even have to call our LLM, which can be expensive. We can instead use a kind of pre-populated result or pre-stored result. Okay, and so this is the topic, guardrails and active monitoring. This is what we're going to dig into for the rest of today's session. I am following comments, and Kelsey is helping me here. So if folks have any questions, feel free to type them into the comment on either YouTube or on LinkedIn. Happy to answer. If they don't come up now, feel free to message me or email me. I'm happy to answer questions after as well. Okay, but let's move forward to developing actionable metrics for complex data. So first, to learn a little bit about the WiLabs approach and this idea of aggregate metrics, and why metrics are so important in the first place. So this is a diagram that I want to walk through pretty quickly about the approach that we have at WiLabs to monitoring, and particularly this passive monitoring. There are new diagrams for the active monitoring, but we won't go into detail of that yet. So what we see here on the left are that there's many different ways that data may come to us in different formats. So model prediction data, training data. You might have your data in batch, so meaning that maybe you have a database full of customers and their different features and demographics and different information that we're going to use as features for our model. That's one way that we might see this data, but another way we might see this data is as streaming data, right? So a call to our API with new data that's happening in real time. So all of these different formats can be analyzed in a very similar way. And that is with this idea of using an agent, and we have an open source tool called WiLogs to capture important statistics about your data. So distributions, missing data, summary statistics like median, actually the full distribution of the data, life cycle events, so things related to this. All of this is what I would consider and what we call a profile of this data. And what makes this beautiful and work so well is that this technique of capturing summary statistics and capturing metadata about your data flowing through the model means that we don't even need to see the raw data at all. So you never upload this raw data to WiLabs. This is something, the raw data remains on your machine while you're running. You can get rid of it when as soon as you're done making your calculations. So long as we capture the right statistics about your data that can help us to do this monitoring in the future. So WiLogs is an open source tool that we do to capture these statistics and calibrate which statistics that we're going to calculate. And then we pass this very small, lightweight package of high-level metadata and statistics, right? Never raw data, this high-level metadata to the observability platform. And in that observability platform, we can now see those aggregate statistics. They can be stored, they can be kind of displayed over time, where we can apply different algorithms on top. So forecasting, detection algorithms, that sort of thing. And in the case that you want to pass in a number of important example data points, it certainly depends on your application and your tolerance for privacy, but you're able to pass a number of examples in as well. in case you want to see some raw data. But that's not necessary with our approach, which I think is great. And this works really well at production scale. So because we're doing this calculation, this lightweight statistical calculation on your data, this can be done very quickly and compressed into a very, very small format. And so that means that calculating statistics over millions of rows or more than that even doesn't cost us, the transfer of millions of rows of data. It costs us just whatever it costs to pass along these aggregate statistics, right? So not quite a fixed number of statistics, but really close to that. Okay, and then finally, as I said, you get things like reports and dashboards. You can set up your system to give you alerts on Slack or PagerDuty or email, whichever you'd like. And then triggers and workflows. You may want to set up your retraining of your model to this system where if you see certain statistics occur and certain alerts happen, you decide, let's retrain the model or let's do this other process to look into our data. Okay, and so thinking about how this works at scale, I just wanted to talk a little bit about how do we do data analysis for billions of rows of data, right, in a realistic, very high kind of frequency system. And so I want to start with a very simple analogy here, and this is just calculating things like the median of your data. So there's three main approaches that I think of when trying to think about an aggregate statistic or trying to understand a large amount of data very simply. So one is random sampling. So this is the idea of kind of storing some small percentage of your data so that you can later do further analysis. So if in Python, this might look something like df data frame.sample if you're using pandas, and you can give some fraction, so 5% of your data. But the other two approaches are kind of data profiling approaches. So I mentioned this before a little bit, but a data profile might contain lots of descriptive statistics. So things like the mean, the median, the max, the min, kind of more descriptive statistics about maybe the shape of the distribution, the type of distribution found, as well as other things. So it doesn't have to all be statistical. Some of it is the data types that we see. Maybe these are all strings, maybe they're integers, maybe they're other types. Maybe there are even patterns that we find in the strings themselves. So this sort of extra metadata that you can have about it. We can do things like categorize the data set and create descriptions for the data set, right? So many different things that you can do in a profile, things like cluster your data and understand the number of clusters and the distribution of those clusters. We can conduct data quality examinations, find out how many missing values there are, find out how many repeating or unique values there are, all sorts of things. And there are many tools to help you do profiling, including the YLogs open source package that we'll use not only to profile, but also to send the data to monitor. Okay, so with this idea of profiling, the immediate thing you may think of doing is static data profiling. So this is calculating a number of important metrics. So you get a table of kind of just numbers and names of those metrics. So in pandas, again, in Python, we would use something like data frame.describe, or actually pandas.describe, and pass in a data frame. This is helpful, but has a number of issues. So you've had to predetermine these metrics, and they can be hard to merge together, hard to reason about many of them or kind of combining from different sources. So the third option, the option that we focus on, is dynamic sketch-based data profiling. So this looks quite similar to static data profiling on the outside, but instead of just kind of calculating statistics, we're actually creating data structures and algorithms for summarizing the data, often with error bounds, very specifically, so we can really have a strong idea of how well we're summarizing this data. And we can use this to now combine and get more information. So the code to do that, which we'll actually do in just a couple minutes here, is y.log, pass in your data frame. Okay, so I talked a little bit about some of these pros here. It's highly flexible. It gives you fast access to these metrics. So one thing to think about is collecting the data. So data is very valuable in our world. We do machine learning, so it's likely even that you have databases of data from your customer interactions. Depending on how many interactions you have, these things may have to be thrown away. Actually, when I worked at Amazon in the past, we had to throw our data away because we did so many calculations that we could only retain it for a very, very short amount of time. But even if you keep and retain this data, the cost of looking into issues, which can happen quite often, is the analysis. So you need to download that data back from wherever storage environment you have. You need to, load it all up, which likely doesn't fit into memory, and do all of this amount of calculation just to get some really basic metrics sometimes. Sometimes all you really needed, it was a sense of the distribution, the median, the 5th percentile, the 95th percentile. And using data profiles allows you really fast access to all of these key metrics that are important for debugging models and understanding how your model's working in production. It's highly flexible, unlike the static data profiling. So because we're capturing things like the statistical distribution, that means you can calculate new metrics on top of that statistical distribution in most cases. It's mergeable. So this is the important kind of thing here when you have multiple machines and thinking about your data over time. So it's one thing to capture data maybe for Tuesday and Wednesday and Thursday and Friday. But if I want to understand, well, what's the distribution of my data for the first quarter of the year compared to the second quarter of the year, I'm going to need to aggregate all of these metrics together. And it's not quite as simple as just taking the average of averages, right? This doesn't work quite that way. It's not transferable in that way. So you need to really have kind of algorithms and data structures that are mergeable. And then some cons are really things that we focus on at YLabs so that you don't have to. So the underlying complexity of some of these metrics and how to get tools to kind of create these data structures. And then just deciding which metrics to actually create and use and which ones are actually helpful for you for debugging production systems. And that's what we focus on and provide out. Okay. So this is kind of an intro to the way that we aggregate data. But if you've tried to use these methods on text or other complex data types, you'll run into some issues about how meaningful your metrics are. So if we had strings of text, let's say we had a different application. This one is a news article. Let's say we're kind of summarizing articles or something like this as a service to our customers. It is not, it can sometimes be helpful to get some very basic statistics about your data. But really, we have some text-specific metrics and concerns that we'd like to include. So we'd like to know things like, well, how many people or organizations or dates are inside of our text? This is a classic NLP task called entity recognition. Or we may want to know, well, if we're using an LLM, is my LLM hallucinating? So this is an example of a hallucination where someone's asking to summarize an article of a web page that doesn't actually exist. And there is a response, right? So this is something that you have to kind of come up with meaningful metrics to help us understand hallucinations and so on and so forth. And this one I like to include just because I think pictures are fun, even though we're going to focus today on text and LLMs. But it can be really difficult to come up with these sorts of metrics for unstructured data. So here in this example, we see on the left a 2014 DC GAN model that produces images of faces. And we see a 2017 iteration of a different type of GAN that is producing images of faces. I think most of us can look at these two sets of images and kind of qualitatively say, well, the ones on the right are better. They have certain attributes and characteristics and so on and so forth that the ones on the left didn't have, right? So imagine we have a model that maybe works in one way, the way on the left, and or works in the way on the right, and then degrades to the way on the left. We certainly want to know this right away. If we want, everyone to get an alert if our model has degraded from the right to the left, right? But how do we do that? How do we find this out? Well, we need to have meaningful metrics, right? So things like the number of pixels isn't going to help us. Things of these basic statistics aren't going to help us. We need kind of very meaningful and context-specific metrics. So sometimes it's fun to go through an exercise of coming up with these on your own. And these are a number of responses that I've gotten when we've had more time to do that. And some of these work and some of these definitely do not work. So number of eyes is one that people inevitably come up with, but that's really difficult, right? So an image is just a number of pixels. How do you measure eye, right? Like that takes a whole nother model in and of itself, and which is something you can do, but something to think about for metrics. So those sorts of things maybe are what we need. But maybe we can use other metrics like the consistency of color across time, right? So a blurrier picture may have more consistency of color, like the gradients are much less sharp. Similarity to some composite face. Maybe if we combined a bunch of faces together, we can at least tell that some of these faces won't be aligned very much with the sort of areas of a head-on picture like this. The ability to predict an attribute using a powerful model. So as I mentioned kind of with the number of eyes, while it's nice to have some metrics that you can calculate kind of independently, sometimes you need to use another model to make predictions to help us to generate metrics that will be more meaningful to us, right? So that's what we can use to find locate the eyes and count the number of them in the picture. We can use other models, right, to predict different characteristics about the people that are in the pictures. And sometimes the inability of your powerful model to be able to predict, say, the age of the person in the picture might tell us that it's a bad picture. Maybe, of course, it's not quite easy to do it that way. So now going over to text again, these are some of the example metrics that we include inside of Langkit for text. So things like text quality, you can start to understand using things like readability score and complexity scores. Things like the relevance of your text, particularly between the prompt and the response, is most interesting. So we can do things like sentence embedding similarity scores. So let's take the cosine similarity between the prompt and response, and that might tell us something about how relevant the response is to the prompt we gave the LLM. We can also do similar things with similarity to user-defined themes or topics. And then a large category comes in the form of security and privacy. So things like patterns, so finding strings matching a certain pattern, such as like social security numbers or phone numbers. Jailbreaks, so these are attempts in the prompt to kind of get the LLM to give a response that wasn't intended. Related to this are refusals. So refusals are situations where the response from the LLM is kind of not a non-answer, often because they detected that you were trying to do something malicious, or at least not within their expectations, and then respond in a more generic way often. And things like sentiment and toxicity as well. Okay, so once we start generating these complex metrics, however we do so, maybe using new models, maybe using regular expressions, maybe using many different techniques, we can now come up with structured data that looks very similar to what we started with, but even for things like text. So now we have rows of sentiment and number of entities and number of organizations and so on. And using these metrics, now these univariate statistics, so this median, mean, range, distribution, missing values, unique values, that sort of stuff, becomes useful again. Okay, and that's all wrapped up in LangKit. So LangKit is the second open source tool that, from Y Labs that I'm going to show you today. And so LangKit is really focused on these text and LLM specific metrics that are then passed into YLogs to do that aggregate statistics so that we can profile and pass that data on to further monitor. And these are some questions that we think about in LangKit. I'll skip that for today, and we've seen these. Okay, so now let's move on to using metrics for active monitoring using manual guardrail thresholds. So now we're getting into the code here at the end. And we have 3 examples that we're going to look at. One of them are written in the notebook as is, and then the other 2 we're going to develop on the fly. So one example of a particular guardrailing scenario is we have an application and the user gives an inappropriate or toxic query. So for example, they may have asked for something highly illegal or immoral, something like this. We would want to detect, in that case, we might want to detect that this has happened. And we could just keep a flag, maybe in a slightly more passive way, just flag this issue for later. But we can also do something more active. So in another example, let's say when the model creates a result that is a refusal, we may want to block this refusal and then do something else instead, right? So so an example would be if a user has asked for something. My go-to example is kind of how to hotwire a car. The LLM application that we're using, our application calls, might say something like, "Oh, obviously I can't tell you how to hotwire a car. That's super legal." And I think that's a pretty good response, but it does depend on your application. So in many cases, what a customer of Y Labs wants to do is denote when this sort of refusal has happened from the LLM, a refusal to give a response, and redirect them, in their system in a more organic way. Maybe it certainly depends on the application. But this is something that you think might be simple, but is quite difficult because the response is coming from an LLM. It's organic. There's not exactly the same words used every time. So you often need more complex metrics to be able to even detect these refusals. And then finally, one of our examples for the notebook we'll see is altering a prompt for removing private data leakage before it's sent to a third-party LLM. So in the first 2 examples, we were really concerned with, well, what did the prompt the user gave to us? Is that toxic? The second one is right before we give a response back, maybe we check it to change it to something more helpful to the user within our application. But if we're using a third-party LLM, another great example is we may take in a prompt or a request from the user, do some processing of it, but before we send that to the LLM, we often want to make sure that there's no private data being leaked to the third-party LLM provider, right? So we don't want to send over their social security number or any legal details or things like this, even though your customers may have been comfortable passing that on to you. So this is another case where you can either, block this interaction entirely, but even better would be to alter the prompt so that we can remove any of the sensitive data before passing on to the LLM. Okay, and with that, let's go ahead and look at the code itself. So I'm going to minimize here, and we'll switch over to the notebook. Okay, I'm going to have to rerun here. So I think I'm reconnected, but for those of you who are joining into the notebook for the first time, what you'll do here, so note that we're going to go ahead and look into WiLabs so we can get some API codes for us. But if you want to do the notebook in totality, you actually are going to want an OpenAI API key if you have an OpenAI account. That's okay if you don't. And then to save this notebook yourself and to make changes, which I'm going to encourage you to do at the end, you need to make sure you're logged into a Google account and then go to File, save a copy in Drive or in GitHub if you choose to do that. But once you save a copy, then you're going to be able to edit it, which is what we want. Okay, so once you've done that, make sure to go ahead and run this pip install here. So it's going to go very quickly for me because I've already installed this on my machine, but it's going to take a little bit of time for you. So do start that running. And then in the meantime, we are going to switch and actually look at the WiLabs platform. So there's a couple ways to get here. My suggestion is hub.wilabsapp.com. There's links to sign up for a free account. So wilabs.ai/free is another way to get here. Actually, maybe that's a little faster to type .ai/free. And here you can go ahead and click Get Started for free if you don't have the account. And put in an email to sign up. Very typical thing. So just put in your email. You'll get an email that you can accept and confirm that that's your email account. And then you can come back and log in. So I already have an account. So I'm going to click on this login here. And mine is set up with Google. You're welcome to use Google or LinkedIn or GitHub that we have integrations for logging in. Okay, but may take you a little bit of time to log in, but I just want to show you the API key that we're going to need for this process today. Let's see if I can make this bigger here. Okay, so if we click on this menu here at the top left, these three vertical bars, we can go down here to settings. I see a question in chat about access to the Colab notebook. There should be links in the comments, in the YouTube comments right above that say, let's see, Colab notebook. So it was about maybe the fifth or so comment down. Hopefully you see that there. Once we get into settings, we can go to access tokens down here. And I have many access tokens because I've been doing this for a very long time, but feel free to create a new access token for yourself. And you'll get a little pop-up that you'll want to save that access token so that you can set up your machine. Okay, so once you've done that, we will use it very shortly. So getting back to our code here, we have a cell that's going to import ylogs as y. Oh, it says you don't have access to. Okay, let me make sure the sharing settings. Anyone with this link? Okay, apologies. Try refreshing the notebook now. I think I tested this, but I tested it. I must have been logged in my other testing environment. But you should have access now. Just confirm that. It's taking very long. Okay. So our line of code here, ylogs is y, and then we're going to go ahead and initialize our system. If we run this, it's going to give you some questions. Actually, let me try to get the same questions that you're getting here. So I'm going to reinitialize here. But it's going to ask, what kind of session do you want to use? If you weren't able to get an API key, you're welcome to try the YLabs Anonymous approach, but it is much better to use a free account. There's many more features, and some of those features we're going to actually see today. So go ahead with the 1. Okay. And then what you're going to do here is you're going to enter your YLabs API key. Here's another link to the same place that we went, to the access tokens. So you can go ahead and paste that in. I'm going to have to go ahead and paste mine in as well. And then after that, you'll give your organization ID. Sorry, let's see if I can do that. I think what I'm going to do actually is I'm going to run this. Oops, let's stop. I'm going to go ahead and run this as an anonymous session. So we won't see a feature here, but I can show you the more generic approach way of doing this. Okay, so it creates a session. Now we're all ready to get started with ylogs. One thing I didn't note is, so we imported langkit, and included as a dependency of langkit is ylogs, which is how we were able to import ylogs right away. But now we're going to import langkit, and particularly a single module. This module is called LLM metrics. It's just a combination of many of the popular metrics for LLM specifically. So I'm going to import LLM metrics from langkit. And then I'm going to create a variable, a schema variable, that takes in the LLM metrics.init output. So LLM metrics.init. And what this does is this looks at the full list of metrics that we have kind of defaulted for LLM metrics module, or whichever metrics that you've specified, which you can do kind of with different code that I won't show here, and adds this to a variable that we'll now access every time we log our data using ylogs. We can now look and see that, okay, we're going to use these specific langkit metrics. I actually don't think we're going to use these two today, but let's just go ahead and run that anyway. Okay, now let's look at some data. So we have a convenient kind of simple data set of chats or prompts and responses. So we're just going to go ahead and import those and some functions to look at those. And we see here that we have 50 different prompts and responses on various topics. But so these are true responses from an LLM. I forget which one specifically. But you see they contain a number of different things, so some simple ones, but also some kind of bad things, right? Phone numbers and credit card numbers and that sort of stuff. Okay, we can look at the first one here. We see the first one's just hello world, cool. So if you type hello to this particular LLM, it responds world. And now what we can do is log this data. So we can log just like this. This will actually treat this as production data. If you want to change that, it's totally okay to run it. But if you want to change that, and let's say, for example, this was training data, I might give it a name like training data and hit enter here so that it can get stored as training data and treated as slightly differently than this sort of production batch data. So the difference in how it gets treated is that any training or any named data sets that you send are kind of separated off and treated as static data sets, kind of like what we saw in the slides. But any of the other data that doesn't have a name is treated as aggregate data. So all of the data that comes in today can get merged together because we kind of want to treat this as either daily or depending on your settings, but the default is daily data. Okay, so once this is run, you should be able to click on the YLabs app link, and we see some things here because this is a anonymous account here. And we see a number of metrics that have been calculated, right? So we only passed in prompts and responses, but LangKit did the work to come up with all of these different metrics for the data and calculate those. And then when the profiles with this sort of statistical information about the metrics was passed across to YLabs, we can see things like, the platform gives us more features, things like insights into that data. So we see a number of possible issues with the data or notable things with the data, as well as many different ways to view this data. So, so because I didn't upload any actually batch data, we don't see quite the telemetry yet. But let's go back to our notebook and keep going. So profiling your data with YLogs right after you use LangKit is a popular kind of way to go. But in the case of active monitoring, we're actually going to think about just the metrics themselves. So we don't need to aggregate them. We don't need to do all of this because we're not going to quite upload them in this particular example. So what I'm going to do instead is import this extract function. And in LangKit, this extract function, what it does is calculates all of those metrics that are defined by our schema here, and does this calculation and provides them in a pandas data frame. Okay, along with our prompt and response that we passed in. So you can see that, for example, many of these metrics, like sentiment as calculated by NLTK, is calculated both on the prompt and the response. Other ones, as well as the reading ease score, and many of them, not all of them are, so some of them are specific to either prompt or response. Okay, I'll minimize this here. So now let's move on to just what you would do to actively monitor guardrails. I went a little long again today, so what I want to do is maybe run through this quite quickly. So we're going to import OpenAI, and if you have an OpenAI API key, pass that here. And then we are going to create a new logger here. So this code, what it does is we are making just kind of a user application. So actually, I think in the past, I made this to make a recipe with a certain item, but we can say any user request in our application. And we have some code here to make a prompt and call OpenAI. If it doesn't call OpenAI, we're just going to pass on some fake responses. So because I'm not running, because I'm not putting in an OpenAI API key, let's just go ahead and run this anyway. Oops. Oh, there we go. Fake responses, response equals fake responses. We'll just pick one. Yeah, well, for now, we'll just put -1. We'll just always take the last one. Okay. Apologies about that. So let's run that with fake responses -1 there. Then we have a function for the reply, and if it succeeds, and a function for the failure. So guardrailing is all about during the process, after we've made a request and gotten a response, or so after we've made a request, if we've gotten, if we hit a certain threshold, we may throw an error, and that error is an LLM application validation error for this example. And then we're going to jump out and do something different, follow this user reply failure function. And also, if we made it past that and we didn't have a guardrail that triggered then, we're going to go on to collecting a response. And if sometime during that response or looking at that response, we've triggered a guardrails threshold error or trigger, then we're going to do the same thing. We're going to kind of go through this different path of code. But if we've succeeded at both of those, then we're going to go ahead and do the successful route, right? So this idea of guardrailing can be done in many different ways, but this is kind of an example of an implementation of a larger system that you may have. So I think I need to run, let's see here, this. But we have a very simple function. So if I said something like how to make spaghetti, we see that our kind of example, our fake responses just gives a phone number, which is not great, but something that we want to trigger. So the following code, I know I'm at time here. So the following code will help us to define these guardrails. And I just want to say quickly how this process works. So, I'm going to do some imports here. And a guardrail could be something like, well, if our toxicity score is less than 0.3, or it must be less than 0.3, otherwise, I want to throw an error, throw a trigger. And so that's what this is, a toxicity score on the prompt.toxicity field. And if you run all of these things together, we make a new logger for that. We can do the same thing here. So I'll let you to do this. Maybe I'll say something mean, like you're a mean person. I don't know if this will be toxic enough, but something like this. Maybe it wasn't toxic enough. That's totally fine. And you can try different prompts to get that guardrail to trigger. And the exercise for you to do, just to kind of understand how to come up with these thresholds for monitoring, are the three that I listed here. So one for flagging inappropriate or toxic user queries. That's the one that that's already implemented here using this prompt.toxicity. But then exploring the data and finding what other metric might you use for preventing refusal responses sending back to the user, and how might you change that code? And same for altering prompts to remove private data leakage. So there's great metrics inside of Linkit to help you to do all of these things. And then I just want to wrap up with how to do this in a more automatic way as opposed to the code. So as we saw in YLab's Observatory, there's many different tools and workflows, and we're soon going to announce a new workflow, and that is YLab Secure, which includes these sort of guardrails policies. So oops, here we go. So there are different things like bad actors, finding malicious actors or usage. So these sorts of jailbreaks or things like this. And you're able to define what behavior you want to do. Maybe you want to block those, what kind of sensitivity you want, and so on and so forth. So things like misuse of your system or different topics, cost, customer experience, truthfulness, so hallucinations, errors, that sort of thing. And hopefully kind of exploring very quickly maybe the code for the expanded way will really help you to see how like these different combinations and coming up with these different combinations will be really important for those who are running LLM applications. Okay, with that little preview here, I'm just gonna say that again, check out YLogs if you wanna really understand this data profiling and capturing telemetry of any machine learning data that you have. Linkit specifically for capturing text and LLM specific metrics. And then certainly explore the YLab's observability platform more to kind of see insights on the bit of data that we've uploaded and maybe even uploading some more data using the Colab notebook that we have. And with that, I'll leave things there. Here's my email. Bernice@ylabs.ai. Social media is largely at Bernice, so Twitter, all sorts of places, LinkedIn, that sort of stuff. And then here's some instructions about swag if you'd like to do that. thank you so much for joining me. Thanks for hanging out the extra couple of minutes. I'm happy to answer any questions that folks have.